What's up, excellent students? It's Ms. Sorensen here with video 30, expected value and binomial distribution. Let's get started. All right, so recall historically that during the first 3 days in July, the probability of having a smoky sky in Manson is 60% each day. Let S be the number of smoky days. So if you recall, that was our answer. Remember the 0.6s were smoky days, then we went 0, 1, 2, 3, and then not smoky days was 0.4. So we write down 0.4, and then this goes 3, 2, 1, 0, or you can think of it as these two numbers need to add to 3 in this case. And then we're choosing out of 3 days, choose 0 to be smoky, 3 days, choose 1 to be smoky, etc. So I went ahead and I used my calculator and I got decimal answers for that. And that's what I got right there. So these come from just plugging this right into my calculator. So I'm gonna remove this right here. We don't need that anymore. But what I do want to show you is that actually these answers show up in a probability or in a binomial probability distribution table, which is really cool. So remember, our probability is 60%, so we're right here. And we're talking about 3 days, so we're talking about this. So in reality, we're talking about these 4 numbers. Look at this, this is pretty cool. We have an exact match with these numbers right here. How cool is that? Now, this question is kind of the key to what this PowerPoint in this video is all about. How do you find the expected value for the number of smoky days in Manson during those 3 days? Well, what am I really asking? I'm asking, how many days do you expect to be smoky? You know, you could guess, right? You could say something like, I don't know, I expect 2 days to be smoky. Or if you want to talk about maybe over the years, 2.7 days to be smoky. Or maybe 1.9 days to be smoky out of the 3 days. That's what I mean by expected value. What do you expect out of those 3 days? And you can tell we probably shouldn't answer with 0, right? Because that has a very low probability. And we probably shouldn't answer with 3 because that's only a 20% chance. So our answer's got to be somewhere in the middle here with what our expected value is. There is a way that we can calculate what the expected value is on Excel. And to do that, we would basically just list out 64 zeros. Why did I say 64? I multiplied all of these by 1,000. So that gave me 64, 288, 432, 216, and this adds up to 1,000. So if you go to Excel and you list out 64 zeros and then 288 ones, 432 twos, and 216 threes, and we find the average of that, that will give us our expected value. So watch me do this. Okay, I'm going to go to Excel. And please trust me, I have definitely done this. You can see I've got a bunch of zeros listed, specifically 64 of them. And then I scroll down and you can see I have tons of ones. There's 288 of them. And then all the way to the end, you can see I've got 1,000 items. Now let's go ahead and average these. And remember, you press an equal sign and then press average. Okay. And then I need to highlight everything now that I've got that in there. And just bear with me as I select everything. Okay, so I've had everything selected from B1 to B1000. Press enter. And we should expect 1.8 days to be smoky. Very interesting. Now, you're probably saying to yourself, God, I hope we don't have to do that. And if you just got a quick sneak peek of the next thing that I'm going to show you, the answer is we certainly do not have to do that. But it is cool that we can. There is a formula for expected value. All you have to do is take the n times the p. Now, what does n stand for? N is the number of trials. In this case, we're talking about 3 days, and p is the probability of that thing happening. In this case, remember, smoky days, the probability of a smoky day is 0.6. So when I do n times p, what I'm really doing is n, the number of days, so the number of trials, which is 3 days, times the probability of having smoky days, which is 0.6, which gives me 1.8. And if you remember, we got 1.8 in Excel as well. This is basically saying we expect to have around 1.8 smoky days. All right, let's try another one. Let's go back to our dress code violation one. Find the expected value of dress code violations over 5 days. So here, all we have to do is our formula n times p. Well, how many days are we talking about? We're talking about 5 days. And what's the probability of a dress code violation? That's 0.3. So I'm going to multiply this by 0.3, and I get 1.5 violations. So we should expect 1.5 violations in those 5 days. It's kind of like your average, if you will. All right, that's it, folks. Join me back soon for video 31, standard deviation and a binomial distribution. Thanks.